theory of how a single linked list works, and we'll also implement a single linked list using Java inside the NetBeans IDE. So very simply, a single linked list is a list that stores a chain of objects. Each object in our single linked list knows how to find the next object in the chain or in the list. So it operates as a linear data structure. So for our initialization of our single linked list, we have three variables that we'll be using. We'll be using head, current, and previous. The variable head will be used as a pointer to indicate which object or which node is the start of our single linked list. So as we've said previously, each object knows how to find the next object in the list. So each object holds two values. So if we just look back here, if we're treating our objects as a node class, each node holds some data, which will be private object element, and it also holds a pointer to find the next object in our single linked list. So each node is made up of two pieces of data. It's holding a pointer to the next node object, and it's also holding some data. Now the data could be a string, an integer, an object, anything that we want to store or persist in this is fine. So for the simple example we're going to use, we're just going to store some basic strings, i.e. a person's name. So I'm going to take a copy of our node object, and what I'm going to do is I'm going to insert this into our single linked list example. So currently in our single linked list here, we've nothing added. Head is been set to null, current has been set to null, and previous has been set to null. So they're all holding null values. So this indicates to us if head is holding a value of null, our single linked list is empty. So the first thing we can do is to instantiate our node class, i.e. create an instance of our node, which will be our node object. And we just drop it in. So we'll just bring him over here to the left hand side, and we'll start populating it. So we've an instance of our node object. I'm just going to give each node a memory address, and we'll use this to visually represent the pointers that are stored in each object. So for this one, I'll call it A at 1200001, and that's the memory address it's storing. The data that it's going to store, we said we're storing string names. So for the first node object we've created, it's holding a string value, which we will set to Johnny. And the next thing we have to set up is the pointer to next. Now, basically, we've added in a new node object to an empty linked list. So the pointer to next will just automatically be set to null. This indicates that we're at the end of the list. So any object that stores a value of null, i.e. the pointer value that it's storing, if that is set to null, that object is the last object in the single linked list. Now, so we've created our node object. Now this needs to be inserted into our single linked list. So the rule for adding, if we're dealing with an empty single linked list, i.e. nothing stored in on it, we create an instance of our node, we populate the data within the node, and what we need to do is that we need to tell our head pointer to point at the new object we created. So we need to set the head variable to point at our new object with a string value of Johnny, and that's going to be the start of our single linked list. So I'm just going to put an arrow in just to graphically represent that our head value is now pointing at our object, which is A at 00001. So we've one item stored in our single linked list. So head points to the first object. There is only one object in the list, so the object for at of A00001 storing a string value of Johnny, its pointer is set to null, which is basically indicating that it is the only item stored in our single linked list. So let's go back and we'll add another object in. So we're going to add another object into the end of our single linked list. So create an instance of node, and we drop it in. So we have to automatically start populating the data. Once we created an instance of the node, it's going to have a unique memory address. And I'm going to set this to, or I'm not going to set it, it has been assigned a value of a at of 00002. I'm only using the memory addresses just to show the unique instance of each object, i.e. that it's independent and it's a new object of type node, and that when we're setting the pointers, that will show that the pointer itself is pointing at the memory address, i.e. how to find the next object. So this is our new node, has its own unique memory address. We have to populate the data stored inside our node. So I'm going to store a new string inside this object, and I'm going to call it Timmy. And so let's say we'll set it as Timmy. This object that we're adding in, we're adding it to the end of the list, so its pointer to next, or its node pointer, will be set to null, which is absolutely fine. And now this node object needs to be added to our single linked list. So previously, the object storing the value of Johnny was at the end of the list. Now we want to add in a new object, and this is going to be the end of the list. So it's basically this one is preceding or coming after our new object called Johnny. So the object called Johnny now needs to know how to find or how to point at the new object that were added called Timmy. So the object called a out of 0001 needs to be able to point at the next object after this in the list. So we're changing its pointer value to a out of 00002. And what this is doing for us is that when we're dealing with the first object, he will actually know how to find the second object in the single linked list. So this is actually maintaining our pointer here for us. So if we start off on our list, the head pointer tells us that the object named at of 00001 starts our list. It has a value of Johnny, and it also has a pointer value to find the next object in the list, which is at of A0002. So we can move over to this object. It has a value of Timmy, and its pointer to next has been set to null. If its pointer to next has been set to null, this means that it's the last item in the list. So let's just very quickly add one more in just to solidify the example. So when we come back, we want to add one more item to the end of our single linked list, i.e. after whatever else is here. So create our object, and we need to populate the data in our object. So let's say we want to, it has a memory address of a at 00003. Now, the data that's going to be stored in on it, it's going to store a string value for us, i.e. a name, which will be called Billy. So it has a string value called Billy. We've inserted it to the end of the list, so its pointer value is now set to null. And what we need to do is to maintain our chain, is that we need to tell the object named a at of 0002 that it will actually point over to at of A003. So basically we're going to fix the chain. So this value will be assigned to this object. Just pull him over here very quickly. And there we go. So we created a new node object, populated its value, and maintained the links between the existing single linked list. So previously, at of 0002 was the last object in our list and its pointer was null. We want to add in a new node object that's going to be at the end of our list. So the at of 002 is no longer last, it's second last. So it needs to know how to find the next object, which is the new one we've added. So we've assigned the variable inside this object to point at the next object in the list. So if we run through it from the beginning, head knows where to start, which is at this object here, A0001, holds a string value of Johnny plus how to find the next object. So it holds a pointer to the next object, which is A at 0002. So we can move over to this object, holding a string value of Timmy plus how to find the next object, which is the pointer to at of A003. So we can move over to this object. Now we have a object holding a string value of Billy, or our node, and its pointer value has been set to null. So this is telling us that this object is the last object in our single linked list, i.e. we're at the end of the list. So the next thing we're going to look at is being able to add a new node object into the middle of our list, i.e. so we'll add a node that's not going to be at the end of the list. So if we wanted to add something that's going to be into the start of the list and or between existing nodes that are in our list, we'll see how this is done. So we will be using our pointer to current and pointer to previous to allow us to maintain the links or maintain the chain between our single linked list.